Well, everybody, we are on our initial pass. I'll have to back up and show you some more of this setup. I had a friend in here while I was setting up, and I try not to put people on camera. But anyways, you'll get to see more of it when we flip this end trim. But we're in here taking our first cut right now. About to back out and see how she's looking once. We're feeding with the table, obviously. Alright, I'll show you guys what we got for setup. So this is a big boring head that takes these Valinite easy sets. So I've got one of those in there. And first cut, I don't even know what I was cutting because I just bumped it out till I made contact. I'd say probably 10 on a side. Not that much. Probably, 10 on a side. So anyways, it cuts like a dream, which is ductile iron is one of, other than the dust, one of the nicest things to cut you can possibly imagine. So anyways, looking really good. I'll take you for a walk around here once now so you get a visualization of Wiggle's been tearing stuff apart here, old dwell meter. So yeah, we have got the old boring mill pretty well working to capacity, I would say. I'm setting on 6-inch 246 blocks here. I only had 2 of those, but I had a set of 6-inch parallels, and I mic'd them, and the difference between them in height wasn't measurable with the tools I had. So anyway, and obviously it didn't super matter because I swept the face of this. I'll show you guys what I've got set up. Wrong drawer. So I made this, which is just a ground 3/8 bar that I put in a chuck here, right in the spindle, and then swept this machined face. It was dead nuts on top to bottoms. I'm sitting on machine flats here. That was dead true. So then all I had to do is bump it around side to side until I was the same across that. And then I came in and swept this bore, actually, because those two have to be true to each other. And this is the one that was hurt, the one I'm machining. So I swept the unhurt bore to nail down exactly what center line was and locked her all down. And now we're just busy cutting away until we get bored out. I don't know exactly where we're going to stop yet. And the reason I say that is I'd like to see... I'd like to see 100 thousandths or so on a side, if not a little more, but we've got, where is it at? Here it is. So I don't want to get into that. That is a bleeder passage. It's not a pressure line per se, but it's bleeder passage, and I don't really want to break through into that because if I do, I'll have a guaranteed leak because it's drilled all the way through. And so if I break through into it, like up here, there will be nothing to stop that leak. I don't know if that makes sense to you. But anyway, so that's kind of the limiting factor. I cannot break through into that passage. So anyway, we'll see how it all goes. Plug away at her. 20 on a side right now. I'm still kind of feeling my way into this. I don't know what reasonable feed speeds and cuts are on the material, the diameter, it's all... Take your best guess at it. It's clearly not taxed at all at this. This is a valuable enough part with enough opportunity for stuff to get screwed up that we're going to take our time and just do this slowly and carefully. So we are turning 54 revolutions a minute. 20 thousandths depth of cut and 5 thousandths per revolution feed rate. I have no doubt it would do more than that, but I'm not interested in pushing it. Just about down to that passage. I'll take you over to the other end and look at one that hasn't been machined on. So the distance between the edge of that hole and the face here, I'm sure is some metric number, but it's really close to 1/4 inch. Or not quarter, 1/8 of an inch. And that was originally my target, was to machine down until I had in my mind just break through that passage, and then that was going to define the thickness of my sleeve. But thankfully, I molded over a little bit more before I actually did that and realized that if I do that, I will have just built a hydraulic leak into this. Because remember from our previous videos, this piston is actually pushing against this face. It's got a step in the piston, it's got a seal here and a seal here. So the pressure is captured between those seals and it's pushing on that shoulder to drive the piston out. It's just a big hollow ring, right? So at any rate, what this passage is a bleeder passage. It's connected up to, right here, you can see this bleeder screw, and the idea is to let them purge the air out of this hydraulic chamber because the fluid comes in here, so you would never get all the air out of it no matter how much you pushed fluid in and let fluid back out. It's not quite as bad as like an automotive brake system because it has actual hydraulic pressure coming from a pump. It's not like in your car where you step on a pedal and you've only got so much fluid, but still it causes a delay in the brakes, and then it might make a delay in releasing actually because you got all that compressed air in there that has to shove its way back out or expand again. So anyways, what I'm realizing, this passage is drilled in straight and it comes all the way through to, past this face that I'm machining on here. I think what I want to do, I've stopped just shy of it right now, but I really don't want my sleeve that thin. I'm going to machine up, I'm on the fence right now. I think I'm going to go with brass. Machine up a brass tube that goes in here. This hole does not need to be this big in order to do its job, to bleed air. Now, granted, it could theoretically trap a tiny bit of air in there by turning it into a tube, but not enough that it's going to matter. So anyways, I'm thinking of taking a piece of brass, turning it until it's, a snug driving fit in here, and that's a sleeve long enough to reach from this face all the way past where I'm machining by a ways, and then drill an 1/8-inch hole down the middle of it. Drive that in there with Loctite on it and let it set up, and then machine through just like I was going to until I skim it. Now I won't have an open passage. Now, yes, I realize that it's possible that, fluid could creep along the edge of that. It's not likely to be a perfect surface, if you want to call it that, where it transitions from the iron to the bronze when I cut through into it. But I'm going to load this whole thing with Loctite sleeve retainer when I put it in, and that will definitely deal with any imperfections there are there. So at this point, that's my plan. I'm going to go ahead and post this video tonight because we won't be back at this. This is Friday night. We won't be back at this till Monday morning. But anyway, pretty excited with how it's working though. The boring mill, by the way, with the new lead screw installed and the adjustments made up here, it is working the best it has ever worked. Just silky smooth on the feed. I always could see something weird before where if you watched the digital readout while it was power feeding, you'd see the numbers speeding up and slowing down. Like there was enough weird, I don't exactly understand. It was just, I think, binding, if you want to call it that, and the screw and nut and stuff, that it wouldn't feed smoothly. And now just silky smooth. I mean, look at this finish we're getting out of this. Now, granted, this is ductile iron, which is as good as it gets, but it's darn near as good as a honed finish. It's doing such a nice job. So anyways, I think that'll be about it for this weekend, and then we'll bring you guys back when we got more to show.